Am I audible? Great. So let's get started with today's topic. So welcome. Welcome all of you. Nice to see you here. So our today's topic is about serverless architecture in the AWS cloud. Sorry about the date. It is obviously a wrong one, but actually this is the date when this slide is essentially completed. And yeah. What we are going to talk about today, it is actually some sort of introductory into the AWS Serverless. We will cover some of the most known AWS Serverless offering. We will see what are the use cases and what kind of architecture can be used for the serverless, and also see a consideration. So whenever you hear about some hot topic, you think, okay, this is solution for any time and anywhere, but unfortunately it's not always the case, and that is the part that we are going to cover in this section titled a serverless consideration. Word or two about myself. So as you can see from the slide, my name is Ivan Milosevic. I'm Senior DevOps Engineer with Data Art, born and currently living in Serbia. So this is not the first time for myself only on a Code Europe, but as well in Poland. So very excited about that. And I really wish to thank Data Art team here from Poland, these guys over there, which actually help this happen and bring me to the Poland. So super excited about that. I'm in an industry for 15 plus years. I started my career as a PHP developer and doing a lot of Linux administration at the very beginning, but then I moved to the dark side and started doing Windows administration. Last 10 years actively with cloud. So in the last 5 years, or maybe a year or two before the COVID, actually I started doing a lot of things related with solution architecture, Docker, Kubernetes, serverless, and those type of the technologies. So yeah, that story about the serverless and thing that I actually did and plan to do on AWS cloud actually bring me to this topic, to talk a little bit about serverless and present it to you people. So yeah, normally when you start learning something new, you would first go to the Wikipedia and I don't know, maybe you will see something like this. If you're a student in some university in Krakow or Belgrade or wherever, when you first Google around serverless, you will find this nasty definition over here. So serverless computing, and sorry, because I have to read it because I don't know it on my mind, so I always need to read this. So serverless is cloud computing execution model, which cloud provider allocates machine resources on demand, resources in general. So actually, there is a very comprehensive definition about what serverless is, but on the other side, it's not easy to remember, and although technically very precise, Wikipedia actually gave a lot of details over here, which is, of course, normal encyclopedia style of defining some things, and, probably I would have hard times remember it, So, yeah, for the sake of, clarity and simplicity, I prefer to use this definition. So, where serverless essentially approach to software design that allow developers to build and run services without having and manage underlying infrastructure. So, does any one of you know who actually created this definition? Anyone? Yeah. That would be me. So, so essentially, of course, it's not me, but I like, simple approach. So if you ask me about serverless, even in a smaller sentence than this one, I would say serverless is focus on code, not on the runtime. Serverless is focused more to the developers, while we as a DevOps or solution architects, we are here just to support some of our operation, unlike some other infrastructure-related models that we are going to see later on, where DevOps needs to participate a lot. Historically, although I don't like a history really a lot, serverless on AWS Cloud is started beginning of this century, and one of the first services was SQS, or simple service queues. So don't worry if you are not familiar with the term, but essentially it went into the beta 2004, and then 2006 it's generally available. Later on, there was a new service, simple notification service, 2010. And if you ask me what happened meanwhile, a lot of things, you know. There were also some services introduced meanwhile, but I'm only giving a list of the most important ones over here, those that are essentially something that I'm going to talk about today. And last, but definitely the most important one from the developer's perspective is Lambda. So Lambda entered the service 2014. And most of the things that I'm going to talk about today is related with Lambda, or Lambda-centric with some integration supported by other two services, plus many others. Somebody actually screwed up my presentation yesterday, so this needs to appear one after the other. Nothing important, essentially. There are Lambda, SNS, and SQS logos. And over here, you also seen that apart from AWS, other cloud vendors, primarily Google and Azure, have similar offers over here. And what is actually very nice to see about these dates. See, 2008, Google introduced App Engine, while Microsoft immediately reacts with the Azure function. So this is very competitive area, and a lot of key players are actually fighting for the market. So that's why these dates and time might look very interesting. So this is actually something that I want to talk about from the financial perspective. I'm not definitely a financial-related person. That's beyond my focus. But why serverless is important from the financial side? As you can see, this is a diagram made by DataBridge Market Search. So feel free to go to their website to find this. Unfortunately, I could not, make better picture or better diagram than this, because you have to pay for it. But all in all, I want to show you something related to here that has to do with the interests of the key players and growth of the serverless architecture market. So yeah, we are currently 2023, of course, but we could see very stable trend of growth, which is projected to be 57.92 billion by the end of this 2022. So what are the key factors for this? What happens here, there are multiple things actually driving this growth. One of them is cloud adoption. More and more enterprises are shifting to cloud. And for serverless, it is essentially a native environment. Serverless primarily runs on the cloud, and that is one of the key factors. Another one is the edge computing and IoT. So more and more solutions are created that way, getting popular that way. Social media is also third factor, and all of this essentially helps very steady growth, and that's why, as I said, all of the key players are very keen to have a strong footprint on the serverless. When it comes to those key players, there are huge or very big number of them, but let's say that Google, Microsoft, IBM, and of course, AWS are the most important ones. And what I actually want from you to remember is this point, 58 billions. I believe that currently, I honestly didn't do actually full research, but I think that annual income of, for example, Azure Cloud is less than this. AWS is more, but everything that Microsoft profits from the cloud is less than what's projected for the serverless at the end of this decade. So yeah, remember it, 58 billions. When it comes to the AWS, being, let's say, biggest and oldest from perspective of income, from perspective of historical presence, AWS, of course, wants to have actually huge offer of services. We will just scratch the surface and see some of the most important ones. But AWS Serverless offering, as you're going to see, it's very, very important. And those services are concentrated in several groups. I will try in 1 or 2 sentences to explain each and one of them, starting with the compute, where Lambda, as a function, as a code, so to say, is probably the most famous one. So Lambda drives dozens and dozens of AWS applications. You see when it's introduced, so it's almost 1 decade old, very popular. It has strong growth, and as you're going to see today, it really has a central place in many of the infrastructures. If you're not familiar with AWS in general, there is a thing called AWS Fargate. So definition and definition again. It's nothing more, of course, it's much more, but definition-wise, AWS Fargate is Docker as a service. You create your definition, put it to AWS, and these guys will do the rest. So they will run your containers. No servers, nothing. Second group is what you already have seen on the previous, one of the previous slides, and it comprises of several services. One of them is SQS. So SQS is essentially a message broker, which is capable of doing dozens and thousands of messages. And actually, it's used, as you're going to see later, into decoupled infrastructure. Then we have SNS. By the way, this is also abbreviation for the largest political party in Serbia, but it's not Serbian national, or how I would translate. Never mind. It is simple notification service. And it has to do with sending a notification not only to the live people, but also to the services. And essentially, primarily, as name implies, is used for notification purposes. Third one is Event Bridge. And Event Bridge, or fourth one, sorry, this presentation was actually rewritten by one guy in my office, and this is not a new set of services, this is number 3, Event Bridge. So Event Bridge is general communication service, so that actually reacts on random events in AWS Cloud. Somebody put the object in a bucket, some sort of notification is sent, and some other service is capable to react on it. Very popular. If you ask me, a little bit underrated service, it can do a really lot of things, becomes more and more popular, but still, I believe people do not use it in a way that it deserves. So, AppSync. AppSync is also something that maybe not be very well known to the non-AWS public, but it has to do with the way how applications are connected with the data and event sources. So you can use like Graph API, you can use pub and subscription APIs to pull data in a real time and present it in your application. Of course, step function. There is a huge limitation with, for example, Lambda. Lambda doesn't run longer than 15 minutes. So if you have like complex task where you need to do something more, let's say, processive, intense in terms of time, you will need some orchestration. One Lambda does one thing, and then another Lambda, for example, does another thing. And the way how it's orchestrated is by this service, AWS Step Functions. API proxy and API gateway, essentially, as name implies, has to do with the way how gateway as a service is presented in AWS, sorry. And whole point of this has to do with the fact that you can get like gateway on demand, gateway as a service. Some of the alternatives for people coming from the Google Cloud background are Google APG, and there is a service in Azure called, I believe, Azure API Management, or APIM. Furthermore, data stores. So this is a very important topic because you said, okay, how I'm going to run the database on a serverless architecture? What if something breaks, you know? But recently, you might not know Amazon Aurora, which is super powerful database supporting MySQL and PostgreSQL. It is not serverless originally, but as of recently, Amazon also has Amazon Aurora serverless offering, which is not fully featured the way how regular Amazon Aurora is, but still gives you a lot of flexibility without to think about the underlying services in terms of sizing, in terms of resource allocation. It can scale insane, you know, but again, doesn't, as I said, support all of the feature. Regular Amazon Aurora does, but still it's quite powerful, and it has its own use cases. Typical one is, for example, when you have non-uniform load, you have those mountains and valleys into your database consumption. So how you are going to, for example, decide what service tier do you need? And in that case, this service actually solves the problem. So it's quite powerful when it comes to the scaling and auto-scaling primarily. DynamoDB, proprietary database, so no SQL database, key value database if you like it. We will see where is the place of the DynamoDB later on, but in general, it's quite powerful service on its own, and it finds its place in wide variety of the infrastructures. Neptune, not sure how much you are in the graph databases, but Neptune DB is essentially graph databases. Concept is very old. It dates, I believe, from 1960s, where IBM, in a space and sorry, not IBM, but NASA, I believe, actually need some data relations related to the coordinates, and now it's very often used for the for this kind of databases, for the graph databases can be found in the social media, for example, for Facebook. So actually they store that kind of information, who are your friends, as a graphs, not as a regular RDMS. Redshift as well. So similarly, as Amazon Aurora has its own Amazon Aurora Serverless, Amazon Redshift also exists as a serverless solution. Again, you don't have to worry about the whole bolts and nodes of warehouse infrastructure. Just, pass it to the serverless, and of course, they will actually. When I say they, I mean AWS will do the care for the other stuff. Amazon OpenSearch might not be the most popular name, but this was essentially Elasticsearch. So what happened? Elasticsearch changed the licensing model, so Amazon needed to react, and actually they created their own version. So it's not only for the serverless, same happened with the regular OpenSearch. With the regular Elasticsearch, now it's called OpenSearch, but principally it is the same thing beyond these licensing reasons. And as you could see, it also exists as a serverless offer. S3, I don't even need to talk about that. One of the first services introduced in AWS. So I think 2004, they created API for accessing the data or objects inside of the S3, and I think now it's in everyday use. Okay, let's now try to deep dive into some of the most common AWS serverless use cases and architecture. As I said, there is no one solution for all, but serverless doesn't work always and for all of the use cases, and these are some of the most common ones. So there are the web applications. So you will see how infrastructure can be set for the web applications to work in a serverless manner without, having web server, without to have a database, without to have dedicated authentication infrastructure and authorization. And that's one of the most famous ones. Another one is data processing. You will see infrastructure in detail over here as well. And for example, use case for this would be, to have some click streams or IoT devices that send their data into huge amount over the AWS cloud, and serverless architecture is with some of the services supporting this kind of scenarios. It's actually capable to deal with this kind of challenges. Batch processing. So you could have a lot of independent processing units. So batch processing, of course, has to do with orchestration as well, and it will actually help to organize this kind of infrastructure. One of the best use cases is essentially batch processing. Invent ingestions. As I said previously, with data processing, similar scenarios over here, but some actually bit different use cases or bit different set of the AWS serverless infrastructure can be used to deal with this kind of challenges. Mobile backends is the last one. So yeah, mobile applications, needless to say how popular they are. And for the mobile backends, we have also, we can actually use serverless in a great deal to simplify our work and to connect our devices to the appropriate set of services, regardless if they are consumers or sources of the events and accessing the data. Okay, finally diagrams. So no more these bullets and everything. So this is typical use case for the web application. Where you have some, fixed objects, for example, profile pictures or whatever stored in the AWS storage services or S3. And that static part is exposed via Amazon CloudFront. So Amazon CloudFront acts as a CDN. It enables actually global access to static content, while on the other hand, for the dynamic content, you have Amazon API Gateway. And that gateway, essentially, as name implies, it proxies the request towards some compute or processing engine. In this case, it's Lambda. And Lambda does its part. So Lambda can pull the data from the DynamoDB, insert data into it, and do any kind of CRUD operations against the data in the database. So let me also not forget about Amazon Cognito. So that is the service that is used for the authentication and authorization. It can be authentication provider on their own, so it can store like user credential or whatever, but in most of the cases it is used as a service which actually communicate with third-party services. Third-party identity provider, Facebook, Google, AWS, Apple, you name it. So essentially, you don't have to worry about the building entire infrastructure. You just need to hook up Cognito with it, and it will do its part. Second part is about data processing. So what happens here? On the right side, there are multiple sources of the data, and there is the service called Kinesis. Kinesis actually collects all of the data and triggers the Lambda function, which, again, stores the data into the database. Key point over here is this left side, or services or data sources on the left side. So it can be, random thing. It can be mobile phones. It can be some even application equipped with the producer library that sends the data into Kinesis, or it can be a web browser. Doesn't really matter. Once this process is triggered from left to right, data are stored in the database, and as such, it can be consumed in a random way. This example actually shows, for example, if you need to do some sort of analysis, so how people react on your post, you can collect all of the, comments and pass it to some custom service that's going, to be, for example, in charge for processing, reactions in terms are they positive, negative. And by the way, there are dedicated services in AWS to do that as well. Batch processing. This one is funny. When I say funny, I mean in a way how it works. Because, again, processing starts with the left side. You push some, let's say, huge file in the Amazon S3. Lambda reacts to it, and it notifies this thing, which is actually step function type of the service, which does the orchestration. What it does, it simply, slices your file into the chunks, stores it in the S3, and notifies next step function. This one over here will do the processing, each and every chunk, maybe extract some metadata out of it, stored it in the DynamoDB, and put it back into the Amazon S3. By the way, upper and lower Amazon S3 can be the same one. So this is just for the sake of the simplicity of the diagram. But at the end, when processing is finished, it will notify main processor. Main processor, will forward notifications toward the email service, and consumer can be notified by email or by some random way. It doesn't necessarily have to be simple email service. It can be whatever. But it will be aware that processing is finished, and consumer can react on it. So as you can see, not only in this scenario, but with all of these scenarios that I've shown, that there are no servers involved. You cannot see some Linux, Ubuntu, or Windows 2019. You don't see disks. You don't see custom-written applications, just to do, for example, event notification or to react on the events. It is pretty much out of the box. But on the other side, don't be too optimistic that it will do everything for you, that you just need, to put all of these puzzles in one place and it will automatically start working. No, that's definitely not the case always. Of course, you need to customize configuration of these services to do proper, for example, data extraction, proper communication, to have, for example, authentication mechanism that one service authenticates to another, and so on and so forth. Ooh, my favorite one. This complex diagram has a lot to do with actually what's available in AWS. But if I actually decided to talk about this, probably would take dedicated slot or a couple of hours just to cover this third part. But essentially, there are three elements over here that you need to be aware of. So that is the data sources, this one over here, or event sources. On the other side, or actually in the central place, there is a thing called event routers, not data routers, which routes events towards something what's known as event destination. And that event destination part essentially has to do with wide variety of the AWS services that are actually capable to react. And most of them, if not everyone, are essentially serverless. So you name it. If you need, I don't know, a training model for your artificial intelligence, use SageMaker. If you need to build custom AMI image, use that EC2 image builder. If you need a RabbitMQ to react on the event, there is an Amazon MQ. And as you can see, many others. What are the use cases? So let's focus on the left side again. Primarily microservice communication. So one service can be essentially an event source, and on the right side you can have another service. Second one is this SaaS integration, or software as a service integration, that actually let you actually send the data or send events from the independent application. Salesforce, for example. Who cares? Not who cares. Salesforce is great, but whole point is that you can actually react on the event coming from the services which are beyond the AWS landscape. Third one has to do, it's kind of selfish in terms of AWS, but it has to do with cross-account and cross-region replication of the data. So you can have some events happening, for example, in the, let me find one funny data center, Middle East South. Yeah, recently I worked for the first time in the data center, which is not in the United States or in Europe. And I say, okay, where is my data center? They say in Bahrain, if I'm not wrong. It's Middle East, and it's Middle East South 1. By the way, there is no Middle East South 2, but there is AWS data center. I was not even aware of the situation in Dubai, and that one is called the Middle East Central 1. So we had a task to do some migration of the Redshift. Sorry, not Redshift, but RabbitMQ. And essentially, we use something similar to this with some of the extents. So those type of, replication that support high availability scenarios are something that is worth of looking into the this kind of architecture is very good example of it. And finally, mobile backends. So like with any other application, like with web application, at the very beginning there is a famous Cognito thing. So Cognito, again, does pretty much the same. And yeah, after being authenticated or after authentication is done, regardless does it come from the service or a consumer that's using mobile device or browser, when that part is finished, you can go into App Sync, Graph API, and navigate through some of the data available there. App Sync, being an API, can pull the data from the OpenSearch service, and yeah, pretty much that part is finished there. But on the other side, again, like with web application, for the static content, you have line above or flow above that actually serves static data to the cloud front. And this S3 bucket in this case is tied with DynamoDB. So there is a Lambda function that acts as a bridge in between DynamoDB from one side towards the Amazon pinpoint. I will explain what pinpoint is and what's the use case in a sec. But on the other hand, when some of the data is injected into DynamoDB, there is a super cool feature of DynamoDB where you literally don't need to do anything apart from enable it. So DynamoDB has something known as the Amazon DB streams. And that is actually place where all of the changes or desired changes are recorded. So for example, some record is changed, updated, deleted, and based on any of these, you can react easily via Lambda. And Lambda actually, can pull that event, process it, and store it, for example, in the Amazon OpenSearch service or Elasticsearch. I keep calling it with this official name. And that way, it will become available to your cache. So back to this Amazon pinpoint, what it does, it is essentially a communication mechanism that from one side enables using different type of communication channels. So it can be like SMS, email, push notification. And on the other side, it has also analytics capabilities. So you can see how actually things are working there, what happens with your notifications, how much people read it, answer to it, react to it, don't react to it. And it's very, very powerful service. Personally, I become aware of this quite recently. And last night, when my colleague and Paulina and I talk about presentation, I told her, yeah, for example, see how they introduce new services. So in general, and let me derive a little bit from the topic, often people tend to create something that essentially goes beyond being aware that there is already pre-created service that can be used in AWS. I am not advocating AWS, don't take me wrong. I'm working for the data art, not for the AWS. But from perspective of the architectural decision or DevOps decision, it is important to understand that sometimes you need to take into account existence of the pre-created services and to see, is it viable alternative to something that you want to create out from the scratch. Little bit more about serverless use cases. Whenever you are architecting in AWS, there is a thing called well-architected framework. AWS collects best practices based on the use cases they have from thousands, if not millions of customers, and this well-architected framework is your guideline when you create any type of the architecture. Pretty much everything happens with the serverless as well. On the other side, there is a thing called AWS Architecture Center. So if you go to the Warsaw for the conference and you need to show some diagram, you don't have to build it on your own, just go there and take it out and put it to your slide. No, that's definitely not the use case, at least not the most important one. But this AWS Architecture Center already has a lot of, so to say, predefined use cases that you maybe want to investigate, and if not 100%, at least you can have decent amount of the architecture proposed that you can use for the specific use case that you are dealing with. Considerations, my favorite part. So one thing doesn't not solve all of the problems, and yeah, there are some considerations to be taken into account. Costs, of course, because with serverless you are paying for, I don't know, in an amount of the, for example, in Lambda, how often you are calling Lambda and for the processing time. Productivity, it has to do with the fact that AWS or serverless does a lot of things for you, so you don't need, as a developer, to take care about multi-threading or a direct handling of HTTP request in code. So serverless, or for example, in case of Lambda, does that in your behalf. Bad side is loss of control. So yeah, you need to be careful about that one. You don't have a control over the runtime. When AWS decide it's time to get rid of the specific version of Node or Python, it's not up to you, up to them, to handle for your code. You need to do that. Security. Okay, this is more my story. Being a DevOps engineer in the, let's say, non-serverless architecture, I can easily install or add some resources which will do intrusion prevention or intrusion detection. That's not the case here. So code has to be built secure from scratch. And this is actually the place where, for example, me as a DevOps engineer need to collaborate with the developers. So they need to write secure code straight away as of the very beginning. And that's how DevSecOps actually is born. Okay, managing state. Why serverless is fast? Because it doesn't have a state. But in case of the state management, you need to deal with that on your own. So you need to have some mechanism that's going to help you with this. Vendor locking, probably the worst enemy of serverless. Why? Because, you cannot pull the Lambda code from, for example, AWS, throw it to Google and expect that it's going to work. No, definitely. You need to rewrite it, or you decide, not to use serverless if you have that kind of problems. Long-running processes, I've touched this a little bit. So yeah, there are limitations for some of the services, how long execution can take, and you need to, take care about that. Alternative, okay, maybe some orchestration tools, or completely dropping out from serverless if it doesn't solve your problem. Cold start. This is not something that is new to the serverless. There are some other solutions that are actually facing similar problem, but occasionally, it could have, not occasionally, but when you first time call your service, it can react a little bit slow. So alternative there would be, either to have some dummy probe that is going to, keep your workload live, or with some cloud providers, and by the way, AWS isn't the one, there is something that is called 24/7, where your infrastructure is, keep live and running and capable responding straight away. But again, you need to pay for it. Scaling, it's not like server type of architecture where you can, say, okay, I want 10 servers at this time, and after, based on some parameter, I want, like 15, or at 5 o'clock, I need 6. No, sometimes it can be actually introduced in the code. And also inner service dependencies. Similar situation is with managed failure. There is some thing called circuit breaker pattern. So you hit one infrastructure or one set of services, and what serverless does, it keep pulling it until it dies or until target service recovers. And if none of that happens, you need actually to introduce something which is called a failover and circuit breakers, so that your application knows where to look if everything is not working fine. At the end, monitoring, tracing, and logging, don't ask me, I really know this is not the easiest thing with serverless, because you don't have full control over the runtime. You need to create a dedicated services that is going to do this in your behalf, or you need to connect with some either cloud or well-known solution to make this happen. Alternatives, yeah, what can we do if serverless doesn't work for us? We can do Docker. Yeah, very popular one. This whale, does its own. So yeah, it's better in a sense of supporting different runtimes. Any kind of programming language will do, which is not always the case with serverless. On the other hand, we have Terraform, or infrastructure as a code. It's it is alternative, or it isn't alternative in some ways. So instead of, create your infrastructure or demand, or in case of serverless, you can create your infrastructure via Terraform and focus on the code deployment there. At the end, Kubernetes. I don't even probably need to talk too much. Everyone are aware of Kubernetes. And if nothing else, Kubernetes can run literally everywhere. On-prem data center or another cloud, or even on this laptop. And there is one strange and very new, at least for me, thing called AWS SAM. By the way, I don't know why they put this squirrel as a logo. In the AWS, you have this, how I said, brick-like logos, but for this thing, it's a squirrel. Don't ask me why. So anyways, this sits on top of the serverless, and it sits on top of the cloud formation. So it's serverless is just one layer beneath, and it utilizes, it's not alternative completely, but it lets you actually create your own layer when you can orchestrate deployment of your infrastructure. Yes, actually, this brings me to the very end. So, questions? If you guys have it, should. Anyone? Come on, at least one. Okay? Sorry, go ahead. Why did I choose AWS? Actually, I did not. So, don't tell anyone. This is just between you and me, but I'm also Azure cloud engineer. From the, let's say, be more open towards anything, and there are clients that are using both. It's not often to see completely. Sometimes, probably at some higher level, somebody comes and say, okay, we as a company A, our strategic decision is to use AWS. But often, not often, but on contrary, sometimes there are clients that actually using both, even three things. Currently, I work for the company which runs everything but Kubernetes on AWS and Azure, and Kubernetes is on a Google. God knows why. I never ask. But yeah, that are the decisions. Thank you. Anyone else? Great question, by the way. Okay? If not, that would be all. Thanks a lot for your attention, and yeah, see you soon. If not this year, then next year in Poland. Cheers.